fifth graders, and welcome back to another, almost our last episode of the Math Show with Miss Condry. And today I want to quickly remind you of our norms, remembering to be respectful and have a positive attitude and keep on trying, especially when it's hard, knowing that even if you don't have it right now, you will with more practice. And today we're going to be working on a concept that is actually pretty tricky to teach in one video, but I want you to know at least a little bit about how to do this learning target for sixth grade. You'll review it next year though too. Okay, so we're going to be talking about our packet. It's the yellow one that I gave to you this week. It is Unit 7, Module 3. I'm actually going to skip the first page because there are videos on YouTube from earlier during this quarantine where I actually talk about these, and I'll make sure that those get posted as well. Here on this next page, which is page 288, is what we're going to be talking about today. So the learning target for today is that we use what we know about whole numbers to multiply and divide with decimals. Decimals and whole numbers are all part of the same base 10 number system. And because of that, the patterns that you guys have noticed over the last several years, multiplying and dividing with whole numbers, will work for decimals. So we're going to go back to what we know. I'm going to go through this quickly. I recommend that you have a pencil and a paper and that you stop and pause the video and jot new ideas down or any posters or words that will help you as you work through this packet. I'm going to jump right in though with kind of a modified problem string. Since we can't be all together in a classroom and you guys figure these out and then talk about the patterns, I'm going to do that for you. All right, so we're going to start by trying to come up with a generalization for multiplication. And we're going to start by thinking about whole numbers because that's how we're going to understand how to multiply with decimals. So 3 times 2,000 is 6,000. As I'm writing these, I want you to think about what you notice. 3 times 200, 600. 3 times 20, 60. Now, if I were to ask you what you notice, hopefully all of you would notice that we're multiplying by 3 every single time. That's staying the same. And also, you might notice that it's losing a 0 each time, right? That factor, 2,000 coming to 220. So it's shifting over one place value, which means it's dividing by 10 each time. And hopefully, you're also noticing that same pattern over here. 6,000 divided by 10 is 600 divided by 10 is 60. So if I were to ask you, I think all of you would be able to say that when we're dividing this factor, 2,000 by 10, then the answer also divides by 10. And this is something that's true all the time with multiplication. So even if we're thinking about decimals, 3 times 1 is 3. But if I keep this 3 the same and divide this factor by 10 to get 1/10, I just have to do the same thing to the answer. Divide that product by 10. And 3 divided by 10 is 3/10. Remember, it just shifts over on the place value. Think about that place value wall that we have in class. All right, and then again, if the 1/10 shifts over one place to become 1/100th, it's dividing by 10, which means we're going to divide our product by 10, and it becomes 300ths. All right, so this is a big idea. We've talked about it this year, and you talked about it in 4th grade as well, but now we're applying it to decimals, and so it's going to feel a little bit new. In multiplication, if one of the factors divides by any number then the answer, or the product, also divides by that same number. It just does the exact same thing as whatever you did to the factor. So here I have an example. 12 times 1 is 12, but 12 times 1/10 will be 1 2/10. We have to divide the factor by 10, so we have to divide the product by 10. Now we're going to practice one of the problems from the page. I pulled an example off of the workbook page, and it is 8/100 times 1/100. Okay, and when you first look at this, it can look a little bit daunting, but if we apply our generalization about multiplication to this, we can solve it. So the first thing I want you to do is I want you to turn them both into whole numbers. So instead of having them as decimals, let's think about them as 8 times 1, which is easy. It's 8. Okay, and now we can change one number at a time, and each time be thinking about doing the same thing. Whatever we do to the factor, we do also to the quotient. Or not the quotient, the product. Okay, so 1 divides by what to get to 100th? Noticing it shifted over 2 places. So that means we divided by 100. That means we have to divide the 8 by 100. Okay, so if I divide that by 100, I divide the 8 by 100, which means it shifts over 2 places and becomes 8/100. Now I'm looking down here, and this time I kept the 100th the same, but I divided the 8 by 100 to get 8/100. Okay, which means I need to divide this 8/100 also by a 100. Oops, I wrote 10. I meant 100 up there. Okay, so 8/100 divided by 100, it has to move over 2 places again. So now it's 8/10,000ths. So whatever we do to one factor, we do to the product. Okay, so I would encourage you, as you're doing these multiplication problems, I would do the multiplication ones first and think about that generalization and turn them into whole numbers and then adjust one factor at a time. All right, let's move on to the next one. If you want to pause and do those problems on your worksheet right now, now would be a good time to do that. Now I'm going to we're going to think about division. We're going to come up with a division generalization. We know division and multiplication are related, but they are not exactly the same. They mean different things. In an equation like 5,000 divided by 500, it's like we're saying how many 500s are in 5,000. And the answer to that would be 10. 5,000 divided by 50. How many 50s are in 5,000? There would be more 50s than 500s. And that answer is 100. Here we have 5,000 divided by 5. How many 5s are in 5,000? That answer would be 1,000. We can check it. 1,000 times 5 is 5,000. 100 times 50 is 5,000. And 10 times 500 is 5,000. Now you might notice that in this case, the first number always stayed the same. That number is called the dividend. But you also are probably noticing that the divisor was dividing by 10 each time. And over here in the quotient, the answer, it was not dividing by 10. It was actually multiplying by 10. And this is because of the meaning of division. It's different than the meaning of multiplication. All right, so now we can apply that to decimals. If it works with whole numbers, it also works with decimals. So 34 divided by 1, I can do that. It's 34. But if I divide it by 1/10, here I've divided that 1 by 10, which means I have to do the opposite thing to the quotient. So I have to multiply 34 times 10, which is 340. Here I divided the 1/10 again by 10 to get 100th. So therefore I have to multiply 340 by 10 to get 3,400. So 34 divided by 100th is 3,400. 400. Now there are a lot of patterns here that I'd love for you to stop and think about because it will make dividing with decimals a lot easier. In division, here's our generalization. If we divide the divisor by a number, then the quotient will multiply by the same number. It does the opposite thing. Okay? We're just talking about the divisor, that second number in the equation. Okay? So now we're going to do some practice with a division problem from your worksheets. If you'd like to pause the video and get your worksheet out, now would be a good time to do that. Okay? So I pulled the problem 7 89/100 divided by 10/100. And just like with multiplication, we're going to change, we're just going to change the divisor into a whole number. So we're going to keep the 7 89/100. We're going to keep that one the same, but we divided by 10. We're going to divide that by 10 and not think about it as a decimal yet. And if I divided it by 10, then that means that this decimal place will move over, or all the digits will shift over one place. So if I do 7 89/100 divided by 10, it's going to shift over and become 789 thousandths. Okay, now I'm going to keep this dividend the same, but I can see here I actually divided this by 100. 10 divided by 100 is 10/100. So that means I have to do the opposite here and multiply by 100 here, which means now this is going to just shift over 2 places. So it will become a 7, and then it will become a 78 9/10. Okay, and then the answer up here, 7 89/100 divided by 10/100 is 78 9/10. All right, as you're working on this today, go slowly and do your absolute best and try and really think about the meaning of the numbers that you're working with and ask yourself, does this make sense? All right, good luck everyone.